Welcome back. Now that you know how and why IPv6 is important for future networking, I'll break down the addresses themselves. In this second of a three-part episode of Cisco Tech Talk, I'll explain IPv6 addressing. Next. When you think about a postal address, you probably imagine your house number, your street name, and your city. Every part of that address matters because it ensures your mail arrives exactly where it should. IPv6 addresses follow the same idea, but instead of pointing to a house, they point to a specific device on the network. Unlike older IPv4 addresses, IPv6 addresses use a much longer format. 8 groups of 4 characters that can include both numbers and letters separated by colons. Here is an example of an IPv4 address compared to an IPv6 address. Wow, IPv6 addresses are so much longer. But the reason is simple. IPv6 accommodates much larger numbers, so you can create far more unique addresses. To do this, it uses a hexadecimal, a numbering system that uses digits 0 through 9 and letters A through F. Fortunately, you don't need to memorize or type these addresses. Your devices and network provider can handle that automatically. To make them easier to read, IPv6 has a couple of shortcuts. You can remove leading zeros in each group, and if there's a long stretch of groups that are just zeros, you can replace them with 2 colons. So a long address like this can be shortened to this. Every IPv6 address has 2 main parts. The network portion is like the city name. It tells the internet which network to send the data to before pinpointing the exact device within that network. The second main part is the interface identifier, which is like the house number. Identifies the specific device within that network. For example, in this address, the first part, 2001:DB8:ABCD:12, is the network. And the last part, :1, points to the specific device. This split between network and device makes it easier for routers to send data to the right place quickly. IPv6 also includes space for a subnet ID in the network portion. Most small networks never use or notice this, but it's built in so larger networks can divide their address space into smaller sections when needed. Take a look at this overview of the IPv6 addressing structure. You'll often see a prefix written after the IPv6 addresses as a slash number, such as /64. This means the first 64 bits of the 128 are the network portion. Devices generate their interface identifiers from the last 64 bits. A /48 prefix means the first 48 bits are the network portion, leaving more bits for creating subnetworks. Think of it like breaking one big zip code into smaller town zones. Think of /64 as your full city and street are set, and the last part is the unique house number. You can think of /48 as your large district is set, but now you can split it into smaller neighborhoods before assigning house numbers. Here's a brief summary of the common IPv6 prefix lengths you may see. IPv6 addresses also come in 3 main types. Unicast addresses are one-to-one, meaning data is sent directly to a specific device, like sending a personal letter. A link local address is a unicast address that is used only in the local network segment. Devices use these to talk to the other device on the same link. They always start with FE80:. Think of them as local-only addresses that never leave your network. Global unicast addresses are public IPv6 addresses that can be used on the internet. They usually start with either a 2 or a 3 and work like a device's public street addresses. Unique local addresses are private IPv6 addresses. They start with FD and are used only inside your own network, not on the public internet. The second main type of IPv6 addresses are multicast addresses. This is used for one-to-many delivering the same data to multiple devices at the same time, similar to a group message. The third main type is Anycast addresses. These are shared by multiple devices, but the system automatically sends the data to whichever device is closest to you, like calling the nearest branch of a business. Even though IPv6 addresses look long and technical, they're designed to make life easier. Most of the time, you never interact with them directly, but they ensure that your data always finds the fastest and most accurate route. That's the basics of IPv6 addresses. Moving on to our last in this series, I'll explain some benefits for how IPv6 delivers data across the internet. Thanks for watching. I'll see you soon.